It's my distinct honor to introduce the moderator of the next panel. He is the longest-serving board member of Tesla and SpaceX, both of which have really transformed industries. And he's an investor in many of the companies that will be discussed over here. He's a GSB alum, and he's a huge supporter of Precourt Institute. He has been in the advisory board for many years and has been my advisor and coach. Most importantly, he's a dear friend. Let's give a big welcome to Ira Ehrenpreis.
Thanks, Arun. Well, good morning. What an incredible week this has been. I had the pleasure of kicking off Tuesday morning with a fireside chat with John Hennessy, and over the last couple days, it's been just incredible seeing so many friends, meeting so many new people, so many leaders of the industry here. Since its inception in 2018, the Global Energy Forum has brought together really some of the most important influencers, leaders, large companies, entrepreneurs, policymakers, together on campus with Stanford's leading researchers and R&D minds, scholars, scientists, financial theorists, and leaders in our field. And it's fitting to have this group here today in Silicon Valley, one of the true epicenters of innovation. Before we begin, I want to congratulate the entire Stanford Energy Innovation Day and Global Energy Forum teams. Especially thank E and Arun, not just for what you've done for the events here this week, but what you do all year long on this campus and for the industry. A huge thanks to Condoleezza Rice and Steve Chu and Bill Perry, to Jimmy, Cindy, and really the entire team who worked so hard to make this event happen and such a success. For the past 25 plus years, since I left campus here on the farm, I've been investing in the energy sector, and I've been privileged to work with some extraordinary entrepreneurs. And the journey has, of course, been anything but straight and predictable. But every day I say to people that I'm more energized than ever about the current moment in history we have and the opportunities ahead to reimagine the 21st century energy economy. As I said earlier this week on Tuesday, in 1995, when I was sitting in seats just like these here on campus, it was a totally different time. If we had tried to gather students here on campus, interested in dedicating their careers to energy, particularly clean energy, it would have been a really small group. There wasn't the Global Climate and Energy Project, there wasn't the Stanford Precourt Institute for Energy, there wasn't the Tomcat Center, the Wood Center, and all the amazing energy-focused institutes that we currently have, and of course, there wasn't the Dorr School of Sustainability. There just wasn't the same level of interest, and any interest that did exist was predominantly focused on perpetuating incumbency. It was new methods of oil and gas extraction or utility operation refinements. Now fast forward to where we are today. This has been an extraordinary transformation. You think about it from a policy standpoint. 20 years ago, federal subsidies largely propping up the fossil fuel production. Today, we're seeing hundreds of billions of dollars of tax credits, incentives to accelerate deployment of zero-carbon technology, incentives to accelerate what we're doing. We're seeing the CHIPS Act, the infrastructure bill, the IRA, which I said, and I keep saying, I'm really privileged that after 27 years of doing this, they finally named some legislation after me. We see corporates, rather than working to slow down climate progress or predominantly using the industry for greenwashing, we now see the leading companies committed to carbon neutrality or sustainable supply chains or supporting the clean energy revolution as never before. On the innovation side, over the past few decades, we've seen massive, massive cost declines in the key technologies that are enabling the transition to renewables. We, of course, know on the solar PV side, module prices coming down from about $76 a watt in the 70s to about $6.50 when I was here on campus to as low as 26 cents per watt today. And it's not just solar. When we think about the storage industry, the cost per kilowatt hour of storage, or the cost per lumen of LEDs, and the list goes on. And it's not just the massive cost declines. Think about the breadth of industries that are innovating today. It's no longer like those early years where it was just solar and storage and biofuels and electric vehicles. Instead, it's morphed into this economy-wide transformation, encompassing everything from agriculture to natural solutions and beyond. And of course, the most important barometer for where the future's heading, and for me, the most important reason for optimism, is the set of world-class executives and entrepreneurs that are attracted to and really focused on the industry today as never before. In the early days, it was once a small group of committed energy stalwarts, idealists, has now turned into this massive movement of attracting the best and brightest founders and executives of our time. This is our moment. It really is the true renaissance time for the industry. We're seeing unprecedented policy, capital, innovation, and talent. But we're also at a pivotal moment. And as exciting as the convergence of these trends are, so much more is needed. We've all seen the data in the past few weeks ahead of COP27 showing that countries are falling materially short of their climate goals, and that it's going to take trillions more than we even expected over a sustained period of time to innovate and change to our low-carbon future. We have to think about this change happening faster. We're going to have to think about innovating and scaling faster than ever before. And these challenges are daunting, but more importantly, the opportunity has never been more exciting. The entrepreneurs, the innovators, and the leaders on today's panel represent the breadth of this opportunity. They represent the quality of talent in the industry, and they represent the passion that's needed to create a new 21st century economy. It's my sincere pleasure to introduce our 5 outstanding panelists. We have Etosha Cave from 12, the Chief Strategy Officer. We have Jorg Heinemann, the CEO of Enervenue. We have Russ Garcia, the CEO of Menlo Micro. Jennifer Nuckles, the CEO of R0, and Bill Lenihan, the CEO of ZOLA. So when we think about this energy transition as being one of, if not the biggest economic transformations of our lifetime, what's exciting about this is for us to accomplish it, it's not just one technology, one sector. We need to overhaul so many industries. So many entrepreneurial innovations are needed to tackle the problem. And what's so exciting is that this panel is really the embodiment of that reality. We have a diverse set of entrepreneurs and industries tackling so many parts of the climate solution. Why don't we do a quick lightning round just so we can get into it? Everyone spend just a couple sentences giving a brief overview of what each company does. Bill, let's start with you.
ZOLA Electric, thank you for inviting us here. We are a distributed energy technology company. We operate in the energy access space, 3 billion people across the planet, hundreds of millions of businesses that lack affordable, reliable energy. We do it through an enterprise model. Think of it like a network, device layer of smart batteries, control layer, and application layer. And we sell to the future utilities of the world in the form of integrators and entrepreneurs that are on the ground in these markets that are developing this architecture.
Jennifer?
Hi, I'm Jennifer. I'm the CEO of R0. So R0 exists to protect the shared spaces that we all occupy indoors, to protect the people we care about. You actually can see some of our devices around this room. We have a product portfolio that consists of multiple devices. They're all far UVC and internet enabled. Essentially what they're doing is disinfecting the air and the surfaces in this room so that it's as clean as an operating room. And we sell through education, commercial real estate, healthcare, the public and private sector, and the reason that people are using us is it's much more energy efficient, it's reducing costly HVAC systems, and it's also better for the environment by reducing chemicals and manual labor as well as substrates.
Russ?
Thanks, Ira. First of all, my name is Russ Garcia, CEO of Menlo Microsystems. What we've done is we've taken a material science that GE invented over the last 15, 20 years, basically to reinvent the electronic switch and improve its capability or efficiency by more than 10 times. And we've now introduced that to the market. We call that the ideal switch.
Jorg?
Hi, I'm Jorg Heinemann. I'm CEO of Enervenue. We are commercializing nickel hydrogen batteries. Think of that as a large format battery that does everything from a super fast charge, like 10 minutes, all the way through to days and perhaps weeks of trickle charge. However, it'll last forever, so it'll last as long as a solar panel, perhaps longer, and do it in a crazy amount of harsh climates, as well as can withstand an incredible amount of abuse. So it's an all-purpose battery that we believe can be the category leader for power plants for businesses and homes.
Tasha?
So 12 is a company that came out of Stanford.
I'd have to just say, Etosha, you're actually the veteran of this exact panel. When we did this in 2018, Etosha was the true superstar of our panel, and we had to have her back. So
yeah.
Welcome again.
Really excited to be back. I mean, this is where it all got started. So, 12 is a company that came out of Stanford. Me and my two co-founders were graduate students here. We were part of the innovation transfer, got a Tomcat grant, so thank you, Tomcat. And 12 is a carbon transformation company, so we take CO2 and water and break it down to these atomic building blocks, and then reform those building blocks to make an array of products that you currently make from petroleum. So we lower the carbon footprint of everyday products by using CO2 to make them.
So let's talk about that. So if we are going to solve the world's energy and water and other resource problems that we have, we can't just keep looking at this through the lens of production or generation. We have to think about this as finding more valuable uses for the resources that we do have, taking resources that have either no value or negative value, and finding innovations that can transform them into real value. And that's probably no more important than, of course, in carbon. You're focused on carbon transformation and thinking about waste to value in that context. Tell us a bit more about that, and tell us about the kinds of products that, that you guys enable to either today and or in the future.
Yeah, absolutely. We want to rewrite the story of waste carbon dioxide and see it as a feedstock. So it has that carbon atom that can be utilized to make all these carbon materials. Our world is filled with carbon products, and we want to be able to make them out of CO2. So we've already made jet fuel through a partnership with the U.S. Air Force. We're also making marine fuel. We've made lenses and sunglasses with a partnership with Pangaea. We've made a component in Tide detergent with Procter & Gamble. And we made a car part with Daimler. And so these materials that we made are indistinguishable from their petroleum counterpart. And we can make them using waste CO2. And really, we're focusing on these hard to decarbonize sectors. So industries like cement and steel and biogenic waste from landfills and so forth. There's these areas where, even if we have a 100% clean grid, which we will get to in the future, we're still going to have CO2 emissions. And so we're saying, why not take that CO2 emissions, use it as a feedstock, create jobs, create an industry around it, and have this carbon ecosystem where we can utilize CO2 and transform it and basically create more economic development instead of just having it be something that gets thrown away.
Thanks, Tasha. Arun mentioned the journey that our firm has had with Tesla, having been part of that journey since the beginning. And having now seen the success around the electrification of transportation, what's clear is we need to think about the electrification of the rest of the economy, what's often referred to as the electrification of everything. And we need new technologies that are going to enable the electrification of everything. Russ, I want you to talk about how Menlo Micro Switch does enable the electrification of everything.
Well, so first of all, if you're going to do the electrification of everything, you have to have something that goes in everything, and that's the electronic switch. It's the fundamental basis for everything we build that's electrified. And I mentioned at the beginning here that we're a material science play that creates a switch that's 10 times more efficient, but efficiency is not enough. You have to have efficiency, then you have to be able to scale that efficiency. So what we actually do is we use that material science in what's called MEMS. Many of you probably know what that is. It's microelectromechanical systems, which allows us to significantly miniaturize these devices and then build them in semiconductor manufacturing processes, which then allows us to get thousands of these on a single wafer and subsequently scale. Not only that, it gives you 90+% smaller sizes, 90+% less weight, and you can imagine what all the advantages are when you start looking at building deployment, mobility deployment, et cetera. So combining those together is what then allows this to go in and have a substantial energy impact, but in an economic fashion. If you can think of having high power switches in everything from industrial automation to EV chargers, all the way to the light switches in all the buildings that we live in and work in today.
Thanks, Russ. Jennifer, you referenced the operating room when you gave your intro. And of course, if we were down the street at Stanford Hospital and we were going in for surgery, the disinfection protocol would be highly efficacious and it would be environmentally friendly. Then we walk out of that operating room, we go into our offices, we go into restaurants, we go into our entertainment venue, our kids go to their schools, and that reality would be turned on its head. We'd have a reality of a process that's ineffective, it would be chemical laden, and it would be highly carbon intensive. And the industries, like so many other industries that we are trying to find, which are ones that haven't changed in literally a century, sectors that need real innovation from entrepreneurs who haven't tackled this industry before, and ones that create both a lighter, smaller, faster, cheaper paradigm, but do so, which we call first bottom line, but also creates a second bottom line, and in your case, not only around the environment, but also as a health and social justice issue. Talk a bit about how R0's transformation and innovation is enabling that.
So we started R0 looking at the science behind how people are getting sick. And as humans, we spend 90% of our time indoors, where the pathogens and the pollutants are 2.5 times greater than they are outdoors. And we've all lived this in the past 3 years, right? All of our world shut down at the same time for the first time in humanity in March of 2020. And so what we did was we combined how our pathogens spread. It's predominantly through air, as we've all learned, and we enabled IoT devices, and we have a portfolio of 4, so that we can look at a single room, like this room, use our internet sensors and determine how many airflows you need, how many cycles you need every single hour to reduce the spread of contaminants. We have a portfolio, a multi-product portfolio, as I mentioned, and we sell into very specific verticals that already understand the value of their human capital, and both from a business standpoint as well as from a greater humanity standpoint, and how it is so important to protect the people that are our businesses. And so our products are used, number one, to reduce HVAC systems. We've all seen in the past 2 years, as people have returned to work, which is candidly still difficult for the private sector. Most people are not going back to work, so companies are doing all they can to increase their occupancy rate. We've seen the HVAC systems running 30% more than they ran 2 years ago. And you've all probably seen earnings this week that came out from a number of Fortune 100 companies that are missing their earnings because they're having to run their HVAC systems so high. This is not good for the environment, right? So when you look at commercial real estate, it accounts for 16% of greenhouse gas emissions. Commuting accounts for 8% of the emissions. So when we look at solutions to clean the air, you can't use the HVAC systems. Similarly, you can't use kind of those antiquated systems that Ira was mentioning. I spent 10 years at Clorox. I'm very grateful to Clorox. Clorox disinfects all the surfaces we all love to use as our families in the public environment. However, there's manual protocols that that on average miss 30% of surfaces. So ultraviolet light, far UVC, is disinfecting all the surfaces in here for us right now, as well as the air, not relying on chemicals or manual labor or substrates, which are all damaging to the environment.
I would say 40 million cases of influenza every year that somehow, as a country, we've just taken for granted. For a relatively small, modest amount of money, the question I was rhetorically asked is, do we care enough about our employees or our customers to actually keep them safe where we spend most of our time? Jorg, I want to talk, you talked about the nickel hydrogen battery that you're working on, and of course, this has been a chemistry that's been around for decades, but it had largely been focused on the aerospace industry. And it's been through the innovations that you and the team, and actually through one of the most prolific inventors and technologists here on campus, Yi Shui, developed, that's enabling this chemistry to be used in a much wider sense of application. Talk a bit about how innovation is enabling us to go not just from the niche of aerospace to using this chemistry for a whole set of industries.
Thanks, Ira. Yeah, I think it starts with, I spent a decade in solar, most of the 2010s, and when I got into that, along with many others in this room, I think we all believed investment in solar and investment in batteries would yield results at about the same time. And what happened is solar took off, but batteries, struggled to gain traction. And as we look at the energy transition we're in, it's basically turning the electric power value chain as we've known it on its head. Got variability introduced at the point of generation. Solar and wind are now by far the cheapest form of generation. Deregulation of the grid causing congestion up and down the distribution network. And then at the point of load, all of us in this room will soon be in a position to be able to defect from the grid, along with basically electrifying everything. So that turns everything upside down, and it drives a need for energy storage that can be charged quickly or slowly, depending on when there's cheap power available, then dispatched fast or slow whenever there's a need for it. So think kind of like our lithium-ion cell phones and our EV batteries. However, we like those batteries for stationary use to be able to last a whole lot longer than our cell phones. Ideally, they last forever, close to it, and require no maintenance, and can withstand high temperatures and low temperatures, et cetera. So after a decade in solar, I spent 3 years looking for a battery that basically fits that spec. And I gave up. I figured, okay, energy storage would go the way of polycrystalline based solar panels, and low cost would just take over everything. And I'd given up, and then I got a call from Professor Shui saying, hey, he had this new technology. Well, it turns out it's not a new technology. He had gone back and looked at first principles and said, what would make a good battery that meets those capabilities that I just described? And the answer is use nickel on the anode, nickel on the cathode, and it basically works kind of like a fuel cell in a very, very simple way. And then what his team had done, figured out that had been done. In fact, it worked for 30 years on the International Space Station, the Hubble Space Telescope, and nearly every satellite deployed in the 90s and 2000s. Problem was, it was ridiculously expensive. And then his team figured out, well, that cost was driven principally by two materials. And his team found a way to replace those two materials with basically dirt cheap materials, super simple stuff. And the net result was a battery that performed just as well, but was now at an affordable price and with an opportunity to scale up, and that's what we're doing.
Right. I think one of the most frustrating parts of energy discussions is that when people talk about energy issues, they're often only talking about energy issues in the developed world. And if we're really going to solve the global energy issues that we face, we also have to talk about and deal with the issues in the developing world. And too often here, we take for granted how we can just easily turn on a light switch or wake up and have our electronics, our laptops charged, or even our electric vehicles. And yet, the reality is almost 1 billion people wake up without access to reliable electricity. So we have to think about, how do we transport a set of technologies here in the developed world that actually can work in the developing world? And how do we have to contextualize or modify or think about how we're going to change the technologies that might work in the developed world and make them work in the developing world? And that's precisely, Bill, what you and ZOLA are tackling. Talk about the importance of energy access and how ZOLA fits in.
Well, first I'm going to tell you it's not 1 billion people, it's over 3 billion people, and it's growing faster than any population in the world. It's not just about lack of grid access, it's about unreliability.
By the way, he included in his stat those of us here at Stanford who experienced a blackout recently.
Yeah. Well, it's coming, by the way, here. The emerging market energy issues are coming here, just so you know. Take a little while, but they'll be here. So, you know, you asked the question on technology and how we want to adapt it to emerging markets, and I'm going to tell you that I really want us to stop thinking about that. I want us to start realizing that the problems in emerging markets from an energy efficiency perspective are caused by this notion that we know everything and our technology is the best in the world. Started 100 years ago, grids, great grids. Built great grids, high reliability, high efficiency, high affordability. We said, oh, they're great, let's put them in emerging markets. It's been a total disaster. You can't really show me one emerging market grid that works well. And from there, what you had people and businesses in these regions that said, I need energy somehow. I need reliability, I need affordability. What else can I do? I have to provision it myself, so I bought distributed energy. Distributed energy is really what forms the basis of emerging market energy provision. It's not centralized grid, it's distributed energy. So what do? Developed markets pushed distributed energy in the form of diesel generation or kerosene lanterns, and then you know, maybe some good stuff like Tesla Powerwalls, and nothing against Tesla, they're one of our largest shareholders, but all they did was cause the next problem. So right now in emerging markets, yeah, now you didn't, but it's called the diesel generator industry did it, is you took systems that were built for a different purpose. They're built to back up a centralized grid architecture. My grid goes down, I put a backup system on, I got a nice solar panel on my roof to drive down the cost of energy. It's a Band-Aid to a centralized architecture. That centralized architecture doesn't exist in emerging markets. So what do we have now? We have millions of backup systems in emerging markets that are delivering the highest cost of energy, the least affordability, the lowest level of reliability, and all to people that can't afford it and need it more than anybody. Okay, so that's the nature. We believe at ZOLA that the distributed architecture makes a ton of sense. We do. There's a lot of resiliency and what have you that can come in with this, and the technology is there, but it needs to be different. It needs to be integrated. It needs to control everything. It needs to control all power sources, all loads. It needs to be connected, either digitally connected or physically connected, and it needs to be smart, where you can drive efficiency around this. In fact, it needs to be like a grid, but just in a distributed form. And that's where we believe the market needs to evolve to. In order to do this, you need to build it for integrators. You need to build it for the future utilities of these markets that are developing these networks of distributed renewable energy. Now, the question of technology innovation and how it can be expressed into emerging markets, this is distributed platform architecture. No one does this better than the developed world. No one does it better than here in the U.S. Or when you think of Amazon distributed architecture or Google distributed architecture. So communication layer, the software layer, the connectivity of these systems, that technology should be evolved for emerging markets, and that's where we can learn a lot and we can start to adapt that technology into where we go.
Well said. If you've got a cell phone, hold it up. Hold up your cell phone. All right, what you're holding when it launched would have cost about $5,000, weighed 2 pounds, barely held a call, and now in essence what you're holding up, what was then perceived as a supercomputer. Raise your hand if you have a flat screen TV. When it launched, about $15,000, some actually $20,000, now less than a tenth of the cost. You think about what's happened with energy storage, going from about 7,500 a kilowatt hour to about 135, a 98% cost decline. And of course, in every industry, it's the cost reduction that leads to mass adoption. And that's what we're seeing across the board in our industry in the early phases of a number of our sectors. Jorg, talk about how your approach and the gigafactory that you're in the midst of enabling leads to the kind of cost reduction that ultimately leads to the mass adoption that I described.
Yeah, so there's a couple ways to look at it. So what we did is we worked backwards. We started with what is the material cost of the core elements that we need to store the electrons? And that's basically physics. Think of that as a commodity floor. We'll never get below that. In our case, that's about 2 kilograms worth of nickel. Then we looked at how do we design this thing so that we methodically engineer out the rest of the material costs, get from over 5 kilograms worth of nickel per kilowatt hour down to 2. And we've identified a roadmap to do that with a specific set of engineering initiatives that are time-phased, many of which, the most important ones of which are deep already in the test process. And at the same time, we have scale effects that are needed. Jigar talked about Wright's law, basically doubling capacity to methodically get cost reduction out just based on scale. So we mapped out how much scale do we need, again, backing into this, recognizing that we're a new entrant going up against the huge behemoths building lithium-ion battery packs that will continue to get cheaper and cheaper over time. And so we calculated, all right, we need to be at 50 gigawatt hours a year of global capacity in roughly 6 years. Let's work backward from there. And what we defined for ourselves, we need to have a gigawatt hours worth of capacity of the first phase of our gigafactory operational roughly a year from now. And then we mapped out, okay, what will that cost? Well, let's start with a pilot line that does 1/10 of that. We're doing that in Fremont, California. It'll be operational by the end of this year. It's based on a manual line that we've had in operation for a year previously, where we're already achieving a 95% production yield. And then even within that gigafactory, we can map out, as we design the tooling for it, we can already identify a series of improvements to get more output per step of the tooling. And then at the same time, we're working with our suppliers and having discussions that have shifted rapidly from, Mr. Supplier, will you give us X quantity of this material for input that looks like the following, to, will you sit down, look at our cost roadmap, and commit to delivering volume over an extended period of time, over multiple years, at the cost, at the volume, at the quality that we need. So basically that working right to left is how we're approaching cost and how we know we're going to be able to hit our cost roadmap. That play, by the way, that's exactly what we did in the solar industry in my prior career, which we borrowed from automotive, which borrowed from washing machines, et cetera. So it's been time tested across multiple industries.
I remember a conversation with Arun and E about putting this event on, and we didn't think when COVID hit that, of course, it was going to lead to the number of years of delay. And we've been on screens. Clearly, COVID's upended the way we work, the way we coexist. And it's clear that the world's changed. In some ways, as innovators, we always look for what are those moments where we're not going to go back to the way it was, kind of like the 9/11 moment for airports. And that's clearly what's happened in our physical spaces. We now, as leaders and as we think about keeping our people safe, keeping our employees safe, we need to think about how we're going to keep our buildings safe too. And innovations that are going to enable us to keep people safer, focus on human health, but do so through a sustainable lens, create what we think of as DBL as that double bottom line. Jennifer, talk a bit more about both the health of our population and the health of our planet through the innovation of R0.
So the way that I think about the interaction of the health on the planet versus people is there doesn't have to be a trade-off. And so when you think about the indoor spaces that we're all inhabiting, it doesn't mean that a healthy amount of air needs to be at a high cost. And actually, the events over the past couple of years, when you think about the California wildfires here, have proven that there is a really high cost with overtaxing the energy grid and leading to climate change and leading to fires. So when I think about the activity within a building, there's ways to bring people together in the shared humanity that candidly we've all missed over the past couple of years. And it's not only impacting our own lives, but it's impacting the bottom line, the true bottom line profit of corporations, because they're missing the collaborative workspaces, they're missing the time together, decisions are taking longer. And so I think this is really where technology can play. And what we've done at R0 is we've used technology to enable these devices. And I should note that these devices were brought in to keep all of you safe. They typically would be mounted in the ceiling, and they would look very much like a smoke detector. They would be not noticeable in your office space or in your space. And there's a number of different form factors that we deliver through. So when I think about what each of these devices is doing, it's actually measuring how many of you are close within the 200 square feet that each device is protecting, and how many air cycles have to be running every hour. And we do this with more...
Noticing everyone's getting up and moving toward the devices where they want to sit.
The gentleman right here is in the safest space in the house. And we can continue to do that, right? And this is where technology really enables that, because you know how many people are actually physically present. You know how many times these actually have to circulate. You know what the surfaces are looked for. And we have sensors that many corporations are using to monitor this occupancy so that it's both energy efficient. These devices release significantly less. It's like 70% more, use 70% more, less energy than HVAC systems, which, by the way, were not designed to improve airflow in buildings. They were designed to cool this building that we're all in, right? So we're overtaxing the use of HVAC systems because they're having to circulate the air in and out more rapidly. So this is, I think, where technology really comes into play, and considering how to upend industries that have existed for so long with different forms of delivery.
Great. You know, Russ, you're focused on buildings through a different lens. You're focused on all that wasted energy in all of the power sockets or the light switches or the HVAC circuits in a building. And you're also focused on managing that digitally as opposed to the analog way it's been done traditionally. And you have your own form of double bottom line. Talk about how that's leading to both an economic savings, but also an energy and environmental savings.
Okay, yeah, so it's really interesting because when you look at energy savings, management is a big piece of it. However, if you look at the technologies that we have started to use to manage energy, whether it's in buildings or networks or whatever, those actually cost energy in order to manage, because we're either using transistors that are semiconductors, they're not conductors and subsequently less efficient than a conductor, or we're using old style coil-driven relays that Edison invented 150 years ago that are basically the same kinds of things. So what we're really bringing to bear here is something that you can scale economically, but still then enable the ability to operate it digitally. So it's an electromechanical device built in a semiconductor process, but it's a conductor, and it's substantially more efficient, but now you can digitally control it. And so I can now, everywhere from the circuit breaker box, or actually even further back in the grid, all the way through to the light switch, I can now manage and meter that energy, but do it with a device that's more efficient than anything that's been used so far. So the key to all of that, like I said, is the scale that you can bring that to bear with.
Right. You know, Bill, I want to come back to you. I loved how you described the impact of what you're doing, but I know I every day get approached from entrepreneurs who want to focus on making a real impact across the globe, and you have as much experience as anyone I know being an entrepreneur, focused on parts of the world that actually have challenges in being an entrepreneur there. Talk about some of the challenges you faced, how you've dealt with them, and what advice you give to entrepreneurs who are trying to follow your path.
Well, I think the biggest challenge is the fact that, like me personally, and running the company, is I'm a developed market entrepreneur. But my customer is an emerging market customer, and so that's really the core challenge. then the question becomes, well, how do you solve that, right? Because great technology companies have deep empathy and understanding of their customer, and they innovate around that empathy and around the challenges that your customer have. So, I mean, the lessons learned after, I've been at ZOLA now for 8 years. It feels like 40, but it is one, early on you have to dig in, so I had to travel a lot, still do, but 7, 8 times a year to Africa. We were in Tanzania at the time, and you have to almost commit to living in the environment to understand it better and to deeply build that empathy for the customer. And then the next stage is really around how do you build that empathy into the organization, the organization that you're building and that you're working with. And what I've learned is the first thing you got to do is you got to have customers within your company. So we have 2,000 people, 1,900 of them on the ground in Africa. They're customers. Everybody consumes energy. They're customers. You got to have it all the way up through your ranks. So our CTO is from Africa, our chief commercial officer is from Africa, and our R&D head is from Chile. And then maybe the hardest part for me was, so now we've got 2 million customers, we've got field engineers, we've got people on the ground, we've got leadership that all understand deeply the customer. Well, how do you get all of that information to your innovation? And our innovators are here in San Francisco and in Amsterdam, and how do you program that in? That's around tooling and data communication and analytics. How do you get all that great information to the innovation side? That's the biggest challenge, at least I found the biggest challenge, to build that empathy. And that's, kind of what we continue to work with.
Well said. Etosha, I want to go back to you. In the early days of investing in the sector and being an entrepreneur in the sector, there was so much focus on biofuels. And yet you're actually tackling the issue with a totally different methodology, and one that focuses on carbon transformation. Talk about the advantages and disadvantages of the lens in which you're innovating relative to the other paradigm around biofuels.
Yeah, absolutely. I like to say that the stage of the company we're at right now is that we're sort of power walking through the valley of death, and we're able to read these tombstones of these companies on either side of us, and a lot of them were in this kind of clean tech 1.0 biofuels wave. And what that's allowed us to do is, I guess you could call it last mover advantage, where we can learn from those companies and learn different ways in which we've been able to get to the stage where we are now. And so I would say there's 3 things we've really learned and are taking advantage of. One is to bring in revenue as we scale and de-risk the technology. So we did these proof of concepts, as I mentioned earlier, like the lenses in the sunglasses with Pangaea, because we realized that we needed to build our commercial scale system that's much smaller than our most recent system will be. But we use that to show that we can make these materials, start to build the relationships with our future customers, and bring in revenue that we can then leverage to go to the next scale. And so those sunglasses sold out in 90 minutes. It showed there was product market fit. Those were really expensive sunglasses as well. They were even more expensive than I would have paid organically. There's a lot of people wanted them. So that was one lesson learned of revenue in at a smaller scale. Second is leverage. So we've much as Jorg said, we looked at our system and these electrolysis systems we're looking to build, and we said, okay, what is the core innovation we need, and then the rest, let's leverage the existing supply chains that are there. So we're able to leverage water electrolyzer supply chain, very similar. Our bill of materials are almost 95% similar, so we can take advantage of that mass manufacturing that's already happened. And our team's able to go out and get quotes for some of these pieces and know exactly how we'll come down that cost curve. We're also able to leverage low cost of capital. And so that's kind of a new thing. So, Jigger was here earlier talking about the loan program office. There's also other project financing entities that are focused on clean tech that, understand, what it's like to scale up a new technology and are willing to take those large chunks of those first few plants and say, we're going to work with you and like give you this this debt financing to be able to build those plants. And so that leverage is new. And I would say third, the new thing is that it's a new environment that we're all in. I mean, I think companies need ecosystems around them to survive, and all of us are being able to take that ecosystem that even 5 years ago was very different. I mean, in particular for carbon management, carbon transformation, there wasn't an awareness that you could even do that or would want to, and now there's policy to go behind it, with the new IRA and other things, and there's all of this. Investors are getting to the space who were in deep tech and then realize like, hey, we can also invest in deep tech in climate and see a clear path for companies to be successful. So, we're really excited as we're going through this valley, and we look forward to seeing what's on the other side as we grow and start to deploy our systems.
I want to focus on something that you said, Etosha, and actually open it up. Rapid fire, because I had a few more questions. I want everyone to get a quick shot at answering a few of these. You did talk about the change in policy, and clearly there's been a tidal shift, as we keep talking about on the policy side, and the headwinds are turning to tailwinds. And but let's actually personalize, let's bring it home. It'd be great to not talk about it at the high level, but to actually hear from a couple of you about how policy is actually accelerating your businesses.
Yeah, I'm happy to start. I mean, we have been combing through the pages of the IRA as much as possible. I mean, there's so much.
Please refer to it as IRA.
IRA, yes. So many provisions in there that IRA has. So one, there's one thing is that there's these production tax credits. That means that, so for example, we make sustainable aviation fuel. There's a sustainable aviation fuel production tax credit. So that means, when we make the jet fuel, we get that tax credit right away. We don't have to necessarily do kind of these long-term, complicated sort of tax equity swaps. There is some of that in there as well, but it's sort of, as we make it, we get that credit, and that just helps us get to market very quickly. We've already seen where there's, certain like airline partners and such that have a willingness to pay, and now that we have that tax credit that we can add on to that, we can just, reapproach those customers and say, hey, now we can meet that cost target, so let's have that conversation. There's manufacturing tax credit, manufacturing in the U.S. There's a 45Q was expanded, so you get a tax credit for utilizing CO2, so we fit under that. So those are just a handful of things that other people.
Someone else want a quick rapid fire on it?
Yeah, real quickly. Since we're a semiconductor company, there's an enormous number of policies that are affecting us. So Etosha talked about IRA and money for and policies around energy, which does two things for us. Because we're energy, we enable a huge impact in energy efficiency. That's starting to take effect, but it also creates customers for us. Because they're enabled to go to market faster and therefore adopt the switch technology we're bringing. On the ground, we're spending a lot of time around chips, so there's investment tax credits. There's still a lot of the rules and regulations coming around that, but that over the next 2 or 3 months, I think it'll start becoming more clear. Etosha mentioned it. I heard it in 2 or 3 other discussions. I read it every single day about the Valley of Death. We're marching through the Valley of Death just as you are, and I think that one of the things that I've just in my meetings with DOE, Department of Commerce, Department of Defense, is that's being recognized. The innovators aren't, and not to badmouth the big tech companies, but the innovators are coming from startup companies and small companies like this, and being able to take new material sciences or new inventions and cross that chasm because they don't fit into necessarily an old manufacturing process technology or the process manufacturing technology of the day. And that's really, really key for us. And so we're getting, I think, seeing where money and policy are going to be deployed differently against that. And
you know, one of the things that we say at DBL as an impact investor is that in order to have impact, real impact, we need to have real scale. I can tell you, you're getting a taste of what's so extraordinary here at Stanford, but for me, being involved with E and Arun and through the leadership and being around the table with, I see Jay Precourt and Tom Stevenson and so many others, the focus on not just creating something nice in a lab or nice in small scale, but truly focusing on how to actually deliver through that valley of death and think about how we're going to commercialize at a real scale to create the kind of impact that we're talking about has been the real focus of Stanford's programs. Before we end, talk a bit about how each of you are thinking about how you're trying to avoid the pitfalls of that valley of death, how you're learning the lessons of some of the prior entrepreneurial attempts, how you're identifying the pain points to get to the kind of real scale that we're talking about. Jorg?
Sure. Front end load the risk, back end load the investment required. So we made certain that within the first 6 months of the company that we could demonstrate that the new materials actually worked as good as we thought they did. Turns out they worked better than the super expensive legacy materials we were replacing. And then the second thing we did is went out and validated that the market wants what we need, what we're making. And what we found is we now have 7,000 megawatt hours, 7 gigawatt hours worth of customer commitments, including nearly 2 years worth of firm purchase orders for what we're building as rapidly as we can scale. All of that at average selling prices that's significantly higher than our business plan. So we're completely certain that the market wants what we're building. And then the last step is, okay, the hard part, let's go scale up the factories methodically like I described.
I agree with what Jorg said. I approach things from a jobs to be done framework and think about why the market would hire you to do a certain job. And so being maniacally focused on who your key stakeholders are, what problem they're trying to solve for their workforce, and then continually iterating against that focus. So we start small, we look at key verticals that we can disrupt, and then we get scale within those verticals. And this is a nice intersection of the public and private sectors, whereas we are private sector led, but we are benefiting from government support to the tune of the prior question, just because there's an enormous amount of grant funding right now to keep the future generation, all of our children, safe. And so education is really looking for solutions to make their healthy buildings home for the kids of the future. So we lead with the stakeholders.
Bill?
I wish I had a bottoms-up answer to this. What we're trying to do here is architect a new way of provisioning energy for 3 billion people. And we're trying to do it in markets that are innately volatile, not just volatile politically, but economically, distribution, infrastructure, just volatile. So I think about it more from a business philosophy or a process perspective. For us, you gotta, like I said, you gotta understand your customer and have real empathy. You gotta be open to new ideas because no one knows the answer. Like anybody tells you they know the answer, they don't. You gotta have humility, because you're going to make a lot of mistakes. And I have made more than my fair share. Our company has made incredible mistakes. But what you also need is then the ability, you need a business model, and really I think of it as innovation. You need innovation that can nimbly address that can move very quickly in order to hit the opportunities, but to adjust to the pitfalls and the mistakes that you're gonna make. Again, easier said than done, but those are the themes that we try to embed into the company to address a very audacious goal of energy access, driving energy equality.
All right, I want to end with some rapid fire prognostication. So when E and Arun and the team invite the 6 of us back for the 2032 Global Energy Forum reunion tour, and we're reflecting back at the last decade that we've just had, how are each of your sectors or the industry at large going to look? What's going to be surprising? And what are we going to be talking about? Tasha, let's start with you.
I would be happy to declare that 12 at that point is converting half a gigaton of CO2 per year into some of the materials we use and love today.
We will have skipped the landlines in electrifying everything, meaning instead of building out the transmission networks, most of us in this room will have defected from the grid. Think proliferation of microgrids everywhere instead of, and with all the benefit of energy resiliency, energy independence that comes with that.
Everybody that you know will have an application in their home, in their car, at their office that has the ideal switch technology built into it.
Fire UVC will be the standard for disinfection across all of our shared spaces.
I'm going to jump on the distributed energy theme, but that's already done in our markets. It's going to be done differently. It'll be done through an enterprise model, not through a B2C backup energy model. And the 3 billion people today that don't have access to reliable, affordable energy will have access to very reliable, very affordable energy. And in the meantime, we're going to create hundreds of thousands of jobs implementing this architecture across emerging markets 10 years from now.
I started by saying how excited I am and how energized I am about being at this special moment in time. This is just a small taste of the massive buffet of entrepreneurial activity that's going on in the industry. It's why when I wake up every day and entrepreneurs are coming into our office, the breadth of ideas. When I come to Stanford and see the extraordinary amount of innovation that's happening here, it is what should give us hope and optimism. And each and every one of you, the kind of commitment and passion that you have, you're doing something hard. And so please join me in thanking them for what you do each and every day and for joining us here at this panel. Thank you. Thank you.